Hello students, welcome back. In this video we are going to go through Chapter 3, Section 2, Measures of Variation. Okay, the key concept here is that we are talking about terms such as range, standard deviation, and variance. You might have heard these values before, especially range, but we're just going to talk with them a little bit more. So these are pretty important in statistics, I would say. So let's not just know how to find them, but to actually interpret and understand them as well. Because I'm sure you've heard of standard deviation before, but you might not be able to give me a real definition or really understand how to speak about it with insight. So let's start with the range. Range is the set of data values that is just the difference between the maximum and the minimum. So you take your minimum, subtract it from your maximum, and that's your range. And that gives you like the set of values that all the rest of your data numbers fall between. So that right here, our range is 41.5. We took our maximum, and then we subtracted the minimum from it, and then we got a range of 41.5. Okay, so the next concept is a question. How do we measure dispersion? So let's say that we have the test score results from two classes. In class 1, there was a 40, a 50, a 60, a 70, an 80, a 90, and a 100. So the class mean was 70. On test 2 from a different class, or the test from a different class got 67, 68, 69, 70, 71, 72, and 73. Also has a mean of 70. So both 1 and 2 have a mean of 70. But would you say that there's a difference between the results from class 1 and class 2? Well, yeah. Clearly, class 1 has much larger gaps within the data points, whereas 2, they're much less dispersed. So how do we measure the variation in these data points? That's where we need to use standard deviation. So standard deviation of a sample value, a sample, we use lowercase s, is a measure how much data values deviate away from the mean. It measures dispersion. So just to get with the notation, standard deviation of a sample is lowercase s. Standard deviation of a population is this little o with a little line. Sigma, lowercase sigma is the Greek term for it. So important properties of standard deviation. It measures how much data values deviate from the mean. It is never negative. The lowest it can be is 0, and it's only 0 when all of the data values are exactly the same, meaning there's no deviation. Larger values of S indicate greater amount of deviation or variation, and the unit of measure for standard deviation are the same as the original data values. So in this example, maybe that's a bad example because there's no actual units, but say we were measuring heights of men in inches. The standard deviation would also be measured in inches. Okay, how do you calculate standard deviation? Well, for a standard deviation for a sample, we use this formula right here, or this is a little more complicated. I promise you we will never use this using the formula. I'm just showing you there so I could tell Pearson and Middlesex, oh look, I showed them, but we will do it only using technology. So, side note, I want to pause for a second to offer up some extra credit for you guys. I'm curious to see as to how many of you students are actually watching these videos. So if you are watching this video, congrats to you. I want you to send me an email with the subject saying extra credit from video, and then just say hi to me. And if you do that, by the end of this week's module, I will give you extra credit on a recent assignment. So don't tell your other classmates. We're going to let this be our little secret because I'm only going to be dividing a certain number divided by how many students tell me. So the more people I figure out, well, the less extra credit you'll get. So send an email now. I'm very curious to see who is actually watching these videos. Okay, so how do we calculate standard deviations using technology? Well, you can do it with the TI-84, Excel, StatCrunch, all of them. So here's the steps for how to do it with the TI-84. So enter the data values within a list. Once you do that, hit second stat, and then really just follow these directions. I don't need to read them to you. If you want to quickly see it, I'll show you real quick. I already have a list in here, but to go to a list, we are going to hit stat, edit, and here is our lists. I already have these pre-populated from an earlier example. So I'm just going to clear out a list, and now I'm going to pretend like I want to get the values of this list. Poor example because it just numbers 1 through 10, but you'll get the idea. So once I did step 1, I'm going to go to second stat, go over to math, and then I'm going to go to 7 for standard deviation. I can also do, why am I not there? Okay. Quit out of that first. I should have included that as well. So second stat, go over to math, standard deviation, and I want to say I want to get the standard deviation for list 1. So I got to tell it standard deviation of what? List 1. So to do that, I have to do second 1. The little blue L1 up here. Once I hit second, whatever I hit will now populate not the main number, but the little number in the top left. And then hit enter. And there's your standard deviation. You can also do it by hitting stat, calculate one variable statistics of L1 as well. That'll give you a whole bunch of different points as well. Or you can go back to here and go to math. You can get your min, your max, your mean, your medium, all these different things right from here. So if you calculate the standard deviation of test 1, you would get 21.6. And then the standard deviation of test 1 for class 2, 2.16. Makes sense they're related because this is 10 times more dispersed than this one right here. Okay, you can also do this using your Microsoft Excel. So just hit enter, or equals, I mean, standard deviation. And then the P is for the population, but we actually want the sample. So we're going to do standard, no, they abbreviate it, so just be careful. And then of all these values right here. And then finally, we're going to do it using StatCrunch. Stat, summary statistics, columns, variable 1, compute, standard deviation right there. So there are several different ways for you to be able to do that. Okay, more directions on how to use it using the calculator. Okay. So then the range rule of thumb. The range rule of thumb is a crude but simple tool for understanding and interpreting standard deviation. And this is going to really be the fundamentals of a normal curve that we will use later in this class, and pretty much all the stats too. And we are saying that 95% of all data values lie within 2 standard deviations of the mean. So kind of keep that in mind. I just kind of want to throw out that feeler there. I won't quiz you on that too much yet, but just keep in mind, I'll say that one more time. 95% of all data values will lie within 2 standard deviations of the mean. That could be 2 greater than the mean or 2 less than the mean. So we are saying that if your mean's right in the middle, this would be the mean plus 2 standard deviations. This would be the mean minus 2 standard deviations. So 95% of all data values are going to fall between here and here. So that would make, if this is 95%, then these green areas would be 5% total. So each of these would be 2.5%. Clearly it's not drawn to scale, but you get the idea. So we are saying that a data value is significantly low if it is lower than this point right here, significantly high if it's greater than this point right here, and not significant if it's between these 2 data points. Okay, variance is related to standard deviation, and it is just simply the standard deviation squared. So you can, as you probably guess, do it using the TI-84. If you want to do it using Excel, you just have to do a variance of a sample. StatCrunch, it's actually the same right here. And it's just taking the standard deviation and squaring it. So here's your notation summary. Lowercase s, standard deviation of a sample. Lowercase s squared, standard or sample variance. Sigma, population standard deviation. And sigma squared, population variance. Okay. So here is a very important slide right here. This is an important thing about normal curves. So the empirical rule states that for data sets having a distribution that is approximately bell-shaped or normal, the following properties apply. About 68% of all values fall within one standard deviation of the mean. 95% fall within 2 standard deviations, and 99.7% of all values fall within 3 standard deviations of the mean. Let's show you what that means. So here's our normal distribution right here. Your mean is right in the middle. You find your standard deviation of that sample. So you add that to the mean, gives you this value right here. You subtract that standard deviation from the mean, you get this value right here. We are saying that 68% of all the data values, remember this is just comprised of however many little dots of data points, 68% of all the total data points fall in this range right here. 95 fall between here, and 99.7 fall within here and here. And then these little areas are the respective areas of each. So 68% would be, well, half of 68 is 34, then some rounding would be this little box right here, 33 point here, and then so on and so forth. The mean all the way to the left would be 50%, and then the mean all the way to the right would be the other 50%. And this chart right here, this I will ask you questions about. So this is a very important slide to make sure you understand how to read this as well. Okay, so let's look at an example. IQ scores have a bell-shaped distribution with a mean of 100 and a standard deviation of 15. What percentage of IQ scores are between 70 and 130? Okay. So the key right in this problem is to realize that how many standard deviations are we away from the mean with 70 and 130? Well, 100 plus 15 is 115, plus another 15, 130. So 130 is exactly the mean plus 2 standard deviations. 70 is the mean minus 2 standard deviations. So if everything is between 2 standard deviations, we know from this slide that 95% of all the data values fall between or within 2 standard deviations. And then there's other questions I can ask you with that. Maybe on one end it could be 2 standard deviations, and then on the lower limit it's 1, and then you have to add these 3 areas together. There's different variations I can do with that. So just make sure you really understand how to read this chart. And then in future lessons, we're going to talk about what happens if it's not exactly a whole standard deviation away. What if it's only 0.82 standard deviations away, and how we'll get the areas associated with that. All right, that concludes this section. Any questions? Always email me.